most important thing to understand is AI engineering is not equals to the classical AI ML that you have been hearing, or in fact, you will continue to hear. What is the major difference? So I'll tell you. You might have heard of LLMs being trained on huge data. And this huge data is actually, I mean, you can say nearly whole world's data, whole world's public data. Whatever is present on Reddit or Quora or here and there, whatever can be crawlable, whatever is publicly available, LLMs have been trained over them, right? Now, fundamentally, before, I mean, I'm talking about the pre-LLM era. In pre-LLM era, if somebody had to create a model, then that model was specific for one use case only. So what I mean by that is there was one model for sentiment analysis. Then there was one model for classification, one model for image recognition, one model for tumor detection, one model for handwriting detection, and I mean, one model for translation. So there used to be separate models for separate use cases. And if, let's say, you have a use case at hand for which a model is not there, you had to train that model from scratch. You had to create that model from scratch. Now, creating a model from scratch, training it on data, gathering that data, it used to be a Herculean journey, which not everyone could do. So, for a normal software engineer who just understands how to write code, algorithms, operating system, databases, networks, for him, it was very difficult to get into that territory. It was very, very difficult, right? But then what happened, what truly happened is once people, the AI researchers and AI architects, once they figured out, so they figured out a very important thing. There is a paper, there is a research paper, which is named as, many of you might know. The name of research paper is Attention is All You Need. So when attention, so what is attention we'll not be covering right now because it's a very deep topic. I mean, it's not in the purview of what we are going to do today. But once this research paper was launched and once the world knew about attention, I mean, a lot of people invested into building LLMs. And when they invested into building LLMs, they trained it with whole world's data. And now again, when you are training a model, you train it to do a certain thing, to do a particular thing. So while LLMs were being trained, they were being trained for just one specific thing. And that one specific thing was to simply detect the next best token. Next best token. So let's understand it in very simple terms. So let's say there is something called as an LLM that you're trying to train, and you give it an input. I want to play blank. So let's say this is the input that you give it. And now what this LLM would do is it would predict the best possible next token. Okay, token for now, let us assume that one token is one word. Let us assume that that is not, in reality, that is not the case. But for convenience, let us assume that token means a word. So let's say you give, I want to play blank, blank, blank. The LLM could probably tell you that the most popular game in the world is football. So football would be the best possible next token. So this was what LLMs were trained on, next token prediction. And they became very good at it. So when the training phase of LLMs happen, when the huge, the large training phase happens, this is what an LLM is trained on. But people soon realized that hey, such a system is not much of is not of much use to us, right? So after training, there is something called as post training that happens. In that post training, the behavior of chatbot is inculcated inside. I mean, I'm saying chatbot because many people use LLMs as chatbot. I mean, you literally chat to it, right? So it is during that phase when LLMs are trained to behave in this manner also. So in fact, there are a lot of reinforcement learning and human feedback which happens. Now if you look at it, it's basically a system which takes in some sequence of words and detects what is the next best possible word or token. Now, I mean, classically, when the LLMs have been post-trained and when you use ChatGPT or Grok or whatever, do you know what really happens? I mean, it's really simple to understand. What really happens is, so let's say this is Grok or GPT-5, whatever. When you give it an input, let's say you ask, where is capital of India? Okay. When you give this input, the first thing that happens is tokenization. Tokenization. Tokenization literally means that this thing is broken down into small tokens. Okay. Now, as I said, for now, let us assume that one token is one word. So literally, you have a token where, you have a token is, you have a token capital, you have a token of, you have a token India. And then what happens is that each token is converted into a vector embedding. So you understand what a vector is. Vector is basically, you can think of it like a sequence of so many numbers. So each token is converted into, so let's say for where it is something like 0 0.1, comma 2, comma 3.4, dot, 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 and this is how. So, I mean, each word would correspond to some sort of a vector like that. Okay. So you have basically so many vectors. And then this LLM, it takes those many vectors, performs so many compute intensive operations involving matrix multiplications and all, and then predicts that, hey, what is the next best word corresponding to it? So it might detect that, okay, where is the capital of India? For this, the next best word is Delhi. Delhi. But now what it does is it does not stop at Delhi because it's a chatbot. So it's supposed to return a full sentence, right? So what it now does is it takes all these tokens, where is capital of India, Delhi, performs a second pass, performs a second pass through the LLM, and then the LLM figures out that, okay, all right, now the next possible word is. And then again, it takes all these words, performs third pass, and then figures out that, okay, now the next possible word is the. And then another pass figures out that, okay, it is capital. Next pass, off. Next pass, India. And probably in the final pass, it figures out that now it is the end of sentence. So this is literally how it works. So there are multiple passes that happens, and every time you send a token, you send a sequence of tokens, so many tokens, and it figures out that, yeah, okay, what is the next best token? And then again, the entire thing goes and figures out what is the next best token. So this is the flywheel which continues, and with that, it figures out, a complete response which is to be served to the end user. So whatever story I have told you, this is on a very high level. I mean, there are a lot many deeper elements that function to make this happen. But this is something which is, I mean, you can imagine this gives maybe 100 feet view of the system, that how LLM really functions. It just takes a stream of tokens, predicts the next best token, then again performs another pass, and that is how it kind of just goes on. All right. So this, I mean, if you look at the basics of how a response is delivered, this is literally how it goes. Now, there are a few interesting things over here. So a lot of you might have already used software systems to do a variety of things, right? So you might have taken subscription of some software as a service, some SaaS product, which might be billing you. Okay. So let's say you have taken subscription of some weather API. Okay. So if you are calling the weather API for getting the temperature, humidity, precipitation, and all that, how they might bill you is they would say that, okay, for every API call, we will charge you $0.0005, something like that. So the billing that happens over there happens on per API call or something like that. for a lot of SaaS-based applications. What do you think? What does your common sense say? Will it be the right sort of billing strategy for LLM providers that, hey, if you make one chat request, then we will charge you this much of dollar? Will this be the right pricing strategy for LLM providers? If no, then why? So the answer is this will not be the right sort of, pricing strategy for them. Why? Because if you look at it, the amount of computation that an LLM has to do, and also the memory footprint that it incurs while processing your request, is directly proportional to the amount of tokens which is passing through it. And that being the reason, the pricing that LLM providers quote is based on per token. And if you have ever got a chance to look at the billing page of ChatGPT or some other providers, they literally say that, hey, we are going to charge you X dollars per input token and Y dollars per output token. And what it literally means is that if, let's say, your input request, it contains 1,000 tokens, if one chat, if it contains, let's say, 1,000 tokens, you are going to be charged 1,000 into X. And if LLM generated 200 tokens for that, because generation, the inference, that also has its cost. If it generated 200 tokens for that, then 200Y. So basically your total cost will be 1,000X plus 200Y. And that makes sense because see, the world of SaaS and the world of LLMs is very, very different, because your request processing over here, it is significantly impacted by the kind of request. I mean, how much of tokens do you have in your request? What is your context size? You might have heard of it. So these are the things which significantly impact the costing of it. All right, so what we will do is now we will sneak peek into some code. We will make some API calls and we will look at what are the important AI parameters, and gradually we will try to dive as deeper as possible in today's session. Okay, so what I have done here is, I mean, it's literally nothing. It's just an API call. I have just made a simple API call to ChatGPT. ChatGPT is GPT-4 model. Okay, one more thing. At this point of time, if you believe that I'm a Java developer, I do not understand Python, I'm a C++ developer, I do not understand Python, do not worry about that. You do not have to code. You just follow the key concepts which I am tying to the different lines of code, and you will mostly be okay with that. Okay, you do not need to know Python in and out. Okay, so let's see what we are doing here. It's a simple class. Okay, and in this class, it's like constructor. It's basically like a constructor where I am setting an API. Think of it like a license. So if you sign up with any SaaS product or with any LLM provider, they will provide you an API key, and in every request you will have to send that API key. I mean, whenever you make a request call, that API key has to be a part of it. Then only it will be able to recognize that, okay, this user has this license purchased from us, he's allowed to make the API call, then only your request will be entertained. Otherwise, it will not be entertained. You will get a 401 or something like that, unauthorized error or something like that. Okay, so we are setting the API key. We are setting it from environment file. So I have an environment file here, and inside this environment file, I have a key value pair where my key is this, and the value is a long gibberish API key. So that will be fetched and placed inside this variable, API key variable. And then self.model equals to model. So you can see that by default, I am using model GPT-4o. Okay. And here I have created a client. So this is an open AI client. Imagine this client is your gateway to API. I mean, this is the client through which you can invoke the open AI's API. As simple as that. Okay. And this is a simple method that I have written, chat completion method, which takes the user message, system message, and it takes two more interesting things. These two are very important parameters, hyperparameters. I'll talk about them, but for now, let me just show you what we are doing here. So the most important part is this. So ChatGPT client has a completions.create API. In this completions.create API, we are passing some parameters and getting a response. And whatever response we are getting, from that response, we are extracting something, some content, we are stripping it, and we are printing it. As simple as that. Okay. Now, this is our main. So in main, you can see we have just created an object of our class. And then we have invoked this method, this chat completion method, which I just showed you. So that's all. That's all that we are doing. And then whatever response we are getting, we are just printing that response. Okay. Now, there are so many things here, but let us go step by step to keep things little clear. So see, you can see there are two important things, user message and system message. So I'll tell you what is difference between user message and system message. Uh, from where do you get your token? Once you sign up, you get your token. Okay, for now, do not worry about it. For now, let's look at the major workflow of request response. You will eventually learn how to get token, where to get token from. Okay, so there are two important things, user message and system message. And you can see here what we are doing is we are creating a messages, which is basically a list. And if you look at this list, we are appending something inside it. So you can see first thing that we have appended is this. Second thing which we have appended is this. Okay, let me write it here. This messages is basically a list of dictionaries. It is actually a list of dictionaries. See, what is this? This thing is a dictionary because you have key value, another key value. So you have two key value pairs, and a data structure which consists of key value pairs is called as dictionary. So you have inserted one dictionary in the messages, and then you have inserted another dictionary in the messages. So what I want you to first understand is that this messages is actually a list of different dictionaries, right? Now, the first dictionary which we have appended, just look at the important things over there. The first thing is role and second thing is content. Role, you can see here the role is system and the content is system message, which we are passing. And here the role is user and the content is user message. And for a moment, you can go down and look at what is your user message. So user message is actually like a proper user chat, which user is actually telling to LLM that, hey, tell me a short story about a cat. And system message is something different. So what is difference between user message and system message? At this point of time, also understand that this is referred to as user prompt and this is referred to as system prompt. User prompt is literally what user has requested for. System prompt is a much more abstracted out thing of it. So imagine that there is an e-commerce company which is planning to build a chatbot. Okay, so different users will come and interact with that chatbot. Let's say I am one of the users. I come and I say that where is my order with order ID 101. That message has been written by me. So that is called as user prompt or user message. But then there will be a system message also, which needs to be sent to LLM. Why? Because e-commerce will have a certain set of expectations from LLM. Cab riding software will have different set of expectation. So I'll tell you a system message or a system prompt which an e-commerce company might want to have. An e-commerce company might want to say that, hey, you are an expert assistant for e-commerce based systems, and the users will arrive at you with different queries. If the query is regarding checking the status of an order, do this thing. If the query is regarding giving some feedback or changing some feedback, do this thing. So they are like high level systemic instructions which do not change with different requests. They almost remain same across all the requests. What changes across all the requests is user message, because when user is typing his queries, of course those queries will be different across different turns. So system message is more around the expectation that the system has from LLM. that if this kind of query is given to you, behave in this way. Your tone should be professional, or your tone should be friendly, casual. It depends upon the nature of software that it is. But user message is the real actual thing, the real actual text which has been printed by the user. So that being the reason, let me tell you one more thing. LLMs give a lot of priority to system message as compared to user message, because system message is much more important, right? System message actually guides the behavior of it. And user message can be thought of as one short query which has been fired to it. Does it make some sense? Do you realize the difference between system prompt and user prompt? It's very important to understand. Okay, so you can see like here, does role work even on raw self-hosted LLMs? See, different LLMs might have different expectations for roles. Okay, we will not go into those for now. We will stick to the roles that ChatGPT expects. So ChatGPT usually expects that if the prompt is coming from a user, the role should be user. If it is coming from system, it should be system. And let me tell you one more thing. If there is a response which has come from AI, in that case, the role will be assistant. And you will see that there are different kind of roles that you can have. You can have role as system, you can have role as user, and you can also have role as assistant. So you will see that in the upcoming lines of code which we will be writing. So is there a chance that an LLM does not follow system messages? If yes, then if you have ever worked with Gemini, I think they just have a provision for user prompt, but that is specific to it. Okay. See, I mean, the granularity of roles could differ across different LLM providers. But the important thing that I'm trying to say is that role plays a significant role in the messages that you send. It helps LLM understand that whose expectation is what. User's expectation is this, and user content, and system's expectation is that, and system content. When you pass the conversation history, you also pass what the LLM had replied in previous conversations. So there you specify the role as assistant. So that is how it kind of goes. Okay. All right. So you can see that we have passed the model name. Our model was ChatGPT 4.0. Messages, which is literally list of dictionaries, and you have seen that. And we have passed two more things. What they are, let us not focus on them for now. In fact, what I'll do is, for the sake of simplicity, I'll just remove this max tokens thing. Let us say I don't need it for now. And because I have removed it from here, I'll also remove it from here. And now I'll just make this API call. So I'll save this file, and then I'll come here and I'll make this API call. So it'll take some time. You realize, I mean, they are not, I mean, you do not have millisecond kind of latency here. Yeah, so this is the output that I have gotten. This is the big story which has been created by LLM. So I wanted a story on cat. Tell me a short story about cat. And this has actually given me a short story about cat. Once upon a time in a quaint little village, blah, blah, whatever it is, right? Uh, Now, so as I told you that LLMs, they charge you based on per token. So sometimes after you have done some analysis and figured out that, hey, your costing is getting very high and you are better off with small responses. In that case, you might want to force your LLM to not output more than 100 tokens or 200 tokens or whatever it is, right? Now, one way to do that is you mention that in the prompt, you can mention that in the system message, or the user could also, user could also mention that if that is user specific requirement. But LLMs, they are not deterministic systems, as we all know. They are non-deterministic. So sometimes they may follow, other times they may not. So what is the sure short way uh, to get to it that LLM does not produce more than these many tokens? For that, you use something called as max tokens. So I'll get back to this. I'll revert and I'll put back my uh, max tokens variable over here. And I'll also pass it in my request. Okay. Now I'll save this. and make the, the second request. See, when I have made second request, you can see that the size of response is significantly smaller, but there is one problem with it. The problem with this response is it is an incomplete response. It has abruptly ended. It says vibrant paintings off and then it has ended. Now, this is something which is very bad, right? This is something which we would never want. So in order to handle something like this, you have to tune your prompt and your expected number of tokens accordingly. Yes, exactly. So what you would want to do is you'd want to make a change in your prompt. You would say never uh, respond in more than 100 words, right? So probably you can mention this thing, you can save it, go back and run it. All right, so this is the output that you have gotten. This is a complete output and this is in lesser than 100 words. So basically, whenever you are using parameters like these, you have to be very careful. That is what I'm trying to say. You have to be very careful. You have to tune your prompts accordingly so that LLM behavior is consistent. All right, cool. So this was max tokens. In lot many cases, when you are prototyping a system or doing something like that, you might not even need it. Okay, but I'm just telling it because certain times when you move ahead and when you feel that the costing is very high and you might want to put a limit, then this is something which is useful. The second thing is temperature. This temperature has got nothing to do with 25 degrees Celsius or 26 degrees Celsius. It is nothing like that. Uh, Anybody who knows about temperature, what is temperature? So tell me what happens when temperature increases. When temperature increases, the particles, the atoms, everything moves. There is randomness, right? There is randomness in behavior. So if you want more randomness in behavior, then you go for a higher temperature. And if you want less randomness in behavior, you go for a lower temperature. And let me explain it a bit theoretically to start with, and then we will come back and write some piece of codes. So if you remember, I had told you that LLMs, their major job is next token prediction. Okay. Now imagine, so LLM already has a predefined list of tokens. It's like a dictionary of words that it knows. Okay. So let us say the input to LLM is I love to play, and you have left it like that. Let's say this is an input. Now, what LLM would do is that out of all the tokens that it has in its dictionary, it will assign a probability score to all of them. So let's say one of the token is food. I love to play food. It is nonsense. So for food, the probability will be 0.0000 something, something very less, something very, very small. Okay. For cricket, it may be higher. Let's say 0.000079. For football, it may be something. For other random word, it could be something. So basically what I'm trying to say is for each token or for each word, there is a probability. So there is a probability distribution that you have. And in the ideal case, what LLM would do, it would simply pick that token whose probability is highest. Simply pick that token whose probability is highest. But if it does this every time, then the behavior of LLM will be quite deterministic. You can say it will be quite deterministic, quite focused, and dull. Imagine, see, when I'm telling this, I'm trying to relate it to the real world. When you talk to a person and when you ask him, how are you? If you ask your friend, how are you? He doesn't respond back in the same manner always. He doesn't always say, I'm fine. I'm good. Sometimes he says, oh, it was a bad day. Sometimes he starts by telling a story. But most of the times, he says, I'm fine or I'm not doing well. So those are the responses that he gives. If you are keeping temperature very low, if you are keeping a temperature, so temperature can, it usually varies in between 0 to 1. That is where people keep it. If you are keeping a temperature of 0, then it basically means that you are expecting a very deterministic behavior. Expecting a very deterministic behavior means that LLMs, most of the times, or 9 out of the 10 times, they would give you the response which is very focused and not so creative by nature. Not so creative. But if you keep a very high temperature, then probably 4 out of 10 times or 5 out of 10 times, it might respond you with something which sounds very creative or very out of the box. So temperature is basically a hyperparameter to tune the creativity of responses that you extract out of LLMs, in simple words. Does that make sense? Do you understand what temperature is for? Now, there are different sampling algorithms. Those of you who are wondering about sampling algorithms, there is something called as top K sampling. And then there is, I mean, there are so many of those, but we'll not venture into them. How LLM samples which response, I mean, which token is to be predicted, there are multiple ways to do that. Temperature is just a way to tune it in a way that the response is much more creative. All right. You can even see it in action. Let's say you come here, okay, and let's do an experiment, a very simple experiment. You are saying, tell me a short story about a cat. Okay, you want to hear a short story about a cat, and you are keeping a temperature of 0.0, okay? And then you run this. Let's see what happens. So this is what it says. Once in a quaint village, there lived a curious cat named Whiskers. Whiskers loved exploring, blah, 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 whatever. And now let's tune it to 1.0, and then you run it again. So you can see there is difference. Here it says, once in a quaint village, there lived a curious cat named Whiskers. And here it is saying, once in a once in a bustling market town, there was a curious tabby cat named Oliver. Do you see a difference in creativity? I mean, it's subtle. It's literally subtle. If you are good with English literature and all, then you can sense it. It's the same story, but more flavor of creativity or uh, tone or vocabulary or whatever it is has been added into it. So this is the impact that temperature has. Cool. Next, what we'll do is, I mean, this class was a very, very simple class. We did not do anything here. We just made a chat GPT call and we looked at some important things, some important parameters of API, which were actually important, right? You can play around with temperature. When you go back after the class, play around with tuning the temperature and all. Maybe make an API call for 0, 0.1, 0.2, 0.3. Just see the difference. Just see if you're feeling, and just one call will not suffice. Because I tell you, it picks out of a probability distribution. So sometimes even for 0.9, you might get a very focused response. So if you make so many calls and then analyze the data, if you have time for that, then you will figure out that, yeah, okay, there is actually a significant difference. Will it differ in the way it answers or answer themselves too? Answers could also very much differ. See, if you ask ChatGPT, tell me story about a cat, for different calls, it might tell you. In fact, it will tell you different stories. But if you ask where is capital of India, once it says Delhi and then it says Thiruvananthapuram, it doesn't. It's not going to do that. It's definitely not going to do that. So it understands where to respond differently. And also, I mean, factual correctness will be ensured. That's the thing. Factual correctness will be ensured. And the way the response is served, that could be different. The lingo could be different. The tone could be different. Does that make sense? Okay. So now what we will do is, right now we have just made one call and it does not feel like it does not feel like a kind of chatbot. Let us build a chatbot very quickly within 2 minutes. Okay. So how can we go about building it? So what I have done is, so I have created a class multi-open AI client because there are multiple conversations that I'm going to do here. And you can see the same thing, API key model client. Now here, this chat completion is also as it was. It is exactly the same. There is one class called as start conversation, not class, sorry, method called as start conversation. Start conversation, it has an infinite loop. Why it has an infinite loop? Because I do not want to stop the chat. I want the chat to happen in a round robin manner. I should type something LLM should respond. Then I should type something, LLM should respond. So it's a round robin behavior. And in order to simulate this, I had to use a while loop. So there is an infinite while loop, as you can see. The first thing I'm doing is I'm taking input from the console. I'm taking input from the console. And then if the user input is quit, exit, or buy, then I'm breaking the loop. Because sometimes if user is done with his job, he might want to quit. And this is just a check that if user has not entered anything, forcefully ask the user to enter, so that because it's a round robin conversation, the other guy has to say something for LLM to respond back, right? And now the next thing we do is here, once we have got a user input, let's say once we got a user input, we are actually invoking the chat completion method. And what chat completion method is doing is it actually makes the OpenAI call. When it makes the OpenAI call, it gets some response from there, and then we simply print that response. Okay. Okay, let me just finish the walkthrough of this particular class. Then I'll probably answer some questions which you may have. But you kind of understand what is happening over here. It's just a round robin behavior which is happening. Nothing special about it. Okay. So what I'll do is I'll just run this class. Okay. So I have just run it, and here it is expecting an input from me. So let's say I'm saying, hi. Then the AI responded back, hello, how can I assist you? Now let's say I'm saying, what is 7 plus 6? Then it says 7 plus 6 is 13. Add 5 to it. Do you like this response? Okay, why you do not like this response from AI? Because it should ideally have remembered. It should ideally have known that I'm talking about the number 13. 7 plus 6, 13 is already computed. And when I say add 5 to it, it should do 13 plus 5 and it should tell me 18, right? If I ask, where is capital of France? The capital of France is Paris. And when I say, how far is it from London? Again, this is a nonsensical response, right? Okay, why this is happening is because some of you have already answered it. It loses context. You know, this kind of conversation is just like me having conversation with a person who has an acute short-term memory loss. I mean, you talk to the person and he forgets. You talk to the person and he forgets. So every dialogue you make with that person, he forgets it, and you have to start from scratch. You have to start from scratch. And why that is happening over here? Yes, the conceptual answer is API calls are stateless. API calls are completely stateless. So that basically means if let's say this is your system, and this is your LLM provider. When you send a request to your LLM provider, it does not store that request somewhere. It does not remember that Vivek had sent me a request and this was the request. When we talk to our friend, our brain does it. Our brain has a RAM inside it and probably a hard disk inside it, which remembers the short-term and long-term memory. The LLM providers does not do that. They do not remember the short-term memory. So whose responsibility it is to maintain the short-term memory or conversation history? The more ideal word for this is conversation history. It is your responsibility. See, if you have used the ChatGPT web client or ChatGPT app, then it is that web client or app client which maintains the context, which maintains the conversation history. Who said what? Who said what in which turn? It actually remembers that. And then every next request it makes, it sends that entire history, right? So before going ahead and before we implement this history, let me just share a screen and show something. So as of now, what was happening was this was your system. It was making a request, getting a response, and nothing was being saved here or here. The conversation history was not being saved here or here. These API calls are all stateless calls. But now what we are going to do is we are going to have a memory layer which will maintain the conversation history. Conversation history. So whenever a user fires a query, it first goes to the conversation history. retrieves the history H from here and sends a combination of query plus H, which is the history, to the LLM. When LLM reverts back with a response R, it saves that response R back to the memory along with the query, also the query, user query. Next time again it comes, so this flywheel, it happens like that. Next query comes, again it goes to the memory, fetches the history, sends it along with the query, and keeps on updating it. So this is the classical way to maintain memory at your side. Before we move ahead, is it making sense? Yeah. Okay. Now, how this memory is stored, this you can wonder, this you can think. There are multiple ways to do this. This is a DS algo problem. This is an algorithms problem. You create your own data structure for it, or you store it in a database, right? So for now, what we will do is we will store it in the RAM. We will not be storing it in database for now because we are doing it for experiment purpose. We will store it in the RAM, and whenever we will need it, we'll fetch it from the RAM. As simple as that. That is what we are going to do. So let me just stop screen share and take you guys back. Let me quit this, Control C. Okay, first look at the code. What is the code over here? See, if you look at the constructor, we have everything, but now we have a conversation history, which is a list of dictionary. And you understand why it is a list of dictionary? Because every conversation that happens is like a dictionary, because you have a role, comma something, and content, comma something. So basically every conversation, whether it is from the AI side or from the human side, is like a dictionary, and you want to store a lot of those. You want to store all of those inside a list. So this conversation history is literally a list of dictionary of string, comma, string, right? Uh, of course, now there can be multiple ways of doing it, but this is one very simple way of doing it. Is it making sense why this has been chosen? All right, let's move ahead quickly and see it in action. So now you can see what we are doing is, so whenever this chat completion is called, we put the system message, and then what we do is we do messages dot extend conversation history. What this line does is that in this list, it dumps the entire conversation history. Whatever conversation history we had, it dumps everything inside it. Okay. And then in the end, it dumps the current user query. So if you imagine, the structure of this messages is something like this. At the top, it has system prompt, and then it has the conversation history which happened in the past, and then it has the current query triggered by the user. So that is the bulky messages that I have. And now I have to send this to OpenAI. So now what I do is I pass it all the way, and then I get a response, and whatever response I get, I simply return that response. I strip it and then I return it. But I do not forget to append the user query and AI response inside the conversation history. So the code that you are seeing over here is just corresponding to the diagram that I showed you. Can you relate? Can you relate the code and the diagram? How many of you can? Even 50%, 60%, 100%, whatever it is. But do you see a correlation between them? How it kind of works? Yeah. All right. So now this start conversation method is exactly the same method where you can see that I have added one more option, history. If you type history, it will show you the entire history, which you have had till now. Okay. And then it kind of just goes ahead. So let's just see it in action. So now if I run this, so if I say hi, it says something. Then I say, what is 2 plus 9? It says 11. Then I say, add 1 to it. It says 12. This is what we wanted. Is that even number? It says yes. Where is capital of France. It says Paris. How far from London? And it literally replies. So I told you at the beginning of the class, there are two important limbs of an agentic system. The first limb is this. And what is this? Memory. Because without memory, you cannot converse by maintaining a context. Now, I can see some of you have asked this question, won't it increase the cost? Yes, it does increase the cost, but there is no workaround. There is no workaround, because just imagine that the API calls which you are making are stateless. Okay, so you have to send the state. Some optimizations that you can do is you can curtail the conversation context. See, if the conversation just goes on happening and happening and happening, and if I have been chatting for 1 hour, then it might have a huge conversation history and the payload size could be very huge. So you might have heard of these things. I'm pretty sure you might have heard that the context window of Gemini is in millions and context window of ChatGPT is less. Have you heard these things? So what does it mean? It literally means that, LLM providers, they offer you different context windows. Somebody might offer you a very small context window, somebody might offer you a very large context window and charge accordingly. Uh, so if, in reality, how, uh, see, there are multiple design patterns which can be used to optimize this. I'm not going into this, but what a lot of people do is they follow a sliding window approach. What I mean by sliding window approach is, let's say I'm talking to Abhishek. Do I need to remember all the conversations which I had with Abhishek right from my birth? Do I really need to remember that in order to answer his next question? No. I probably just need to remember the conversation that I had in last 1 hour or last one day. That's it. So there is a sliding window which moves on. So what you actually do is you here, instead of this list, what you can do is you can probably use a queue, right? And you can say that, hey, in this queue, whenever this queue grows greater than 20 in size, the older elements will be thrown away. So only the latest 20 conversations will be sent to LLM. And then LLM will respond accordingly. So this is one way, but this is a lossy way. When I say lossy way, you are losing the previous context, but you are losing it for good, right? You're losing it for optimization. What some people do is, instead of losing everything, they compress it into a short summary and they send that short summary to LLM. So they have fresh 20 messages, and for the previous 20 or 30 messages or 50 messages, they have a short summary. So there are multiple ways in which this optimization is done, and this is what engineering is, and this is what AI engineering is. AI is already there. LLM is already there. What engineering practices you are using to make a system work is what AI engineering is. So this is a quick and short glimpse about it. Okay, at this point of time, if you also want to see how this thing history looks like, you can even type history. And see, this is the real history. User said hi, assistant said this, user said this, assistant said that. So this is the entire history which we are maintaining. And every time a request is made, this entire history is thrown, right? And then the LLM responds. Sometimes what happens, if the history is very high, LLM gets confused. So those things also happen. Okay, we will just, before moving ahead, we'll just like to share something with you in these 2 minutes. I'll just stop my screen share and then we'll move on to the next part of it.
So I just wanted your 2 minutes to introduce the AI engineering program that we are launching. It's like a commercial break for 2 minutes, but we'll also be going through the roadmap. If you are trying to study AI engineering, how it should be like. So I'll just quickly share about the AI engineering program that we have built. So just for context, I'll tell you that Vivek has been working on AI tools. So like building something through AI or a AI product for last 6 months, we are trying to build a new startup. So we have been trying to build a lot of things with AI last 6 months, and then we thought, why not share this knowledge? So that starts on Saturday, on 23rd August. If you have already subscribed, if you have already registered for the program, it will be starting on Saturday. There will be live classes on both Saturday and Sunday, 8 to 10 p.m. IST. So uh, if you if you will be in some other time zone, probably in US, then it will be morning time for you. But in Indian Standard Time, it will be late evenings. Recordings will be available. We usually do not recommend you to watch recordings because if you will be in class, you will be able to ask questions. Recordings usually lead to procrastination, but for the sake of convenience, we have to keep it like that. It will be about 8 to 10 weeks. Usually, our programs stretch little more, so that is why I'm taking a buffer of 2 weeks. It might stretch for a week more, but usually it will be 8 to 10 weeks. You will be building a lot of projects during the course. It will be sort of, you can pick up your individual ideas, build them. We'll be happy to help you with it. And then goes the syllabus. I think Vivek can speak more about how the syllabus is designed and if something else or something more will be there.
Yeah, so we have everything that you need to engineer a product. Okay, so as I told, this is not a classical AI/ML course where you will be learning uh, regression and classification. Andrew NG has a wonderful course on that. Okay, this course is more around how to use LLMs to build something useful. In fact, today in the second half, we'll be building something useful. Okay, and you'll see that. So when you start learning first, it's good to know about some details of the architecture of an LLM, that what really is transformer model, and what are embeddings, and what kind of tokenizer is there inside GPT-4 and how it works. If you know those things, it's better for you to kind of move ahead step by step. And then you learn about a very important thing. You might have kind of heard it here and there: prompt engineering. Prompt engineering is a very, I would say it's the most important aspect of LLMs. But in order to discover the right prompts, it requires a lot of engineering. You have to write evals, and then you have to tune your prompt. So see, one way is that you feel like the prompt is not so good, let's change it. It's the most stupid way to do that. But one way is to run some evals and then figure out what exactly has to be changed and change just that part. It's just like a very precise change that you are doing. So prompt engineering goes hands in hands with hands on hands with evals, which we will be talking about. Tool calling is the next thing that I'm going to talk about even in this class, and it's the most important, I would say, a super important aspect of using LLMs. Then comes agent workflows, how you actually create agent workflows with multi-agent systems. And definitely, see, even for today's class, I could have used a framework like LangGraph or LangChain. It would have made my job very easy. It's very simple to write code in that, but then you do not get to understand what is happening behind the scene. Okay, but in this cohort, we will actually learn the internals of those tools and we will use them as well. Okay, the next very important thing is about vector databases and RAG. So how you can use vector databases and RAG to enrich your requests with much more precise context is the next thing which we will be learning. We'll be building multi-agent systems on top of that. Eventually, we will also learn about what is fine-tuning and distillation. Distillation is about taking in 1% knowledge from a very large model and putting it inside a small model and then working with that small model. It's a very super interesting concept. Similarly, fine tuning. So we'll be touching based on those, and we will be covering the multimodal aspects also, like how do you deal with voice models? What are the, you might have heard of things like automatic speech recognition and transcription, and also, so how do you build a voice agent and what are the best practices of building a voice agent? It is very, very different. So it's a different architecture altogether. And then we will talk about stable diffusion model, and which is more around the images, creating images, and basically not generating images on the go, just via prompting and by changing few hyperparameters. And finally, we'll also be talking about the deployment. If you have built a useful product, a useful software, where to deploy, how to deploy, and how to probably uh, make it live for everybody else to use it. So that is what we'll be covering. Yeah.
I think there are some questions. Will it be based only for engineers? Can non-engineers also learn?
No.
I think if they learn Python, can they do it?
Yeah.
Which language will be used for the course?
Python will be used for the course, but language is not important. What is important is you should have some basic idea around what is an API, what is database, what are threads, what is operating system. So whenever these words come in, you should be able to understand. Model context protocol will be covered. So what is protocol? What is networking protocol? You should have an idea around these things. Some design patterns and all. Yeah.
I think this does the curriculum include fine-tuning models like LoRa and QLoRa?
Yes.
Okay.
All right, so let's get back. A lot of you are asking about MCP. Yes, MCP is covered. Uh, so you can do AI engineering in any language. The only thing is that in Python there are so many supportive libraries. So like you have LangChain, you have LangGraph. I'm not sure if you have competing libraries in other languages also. But I tell you, I did not know Python 2 months back. And way back in 2015 when I was interning it was my first internship with Amazon. My work was in Java and I did not know Java. So it get out from that trap of, doing something in a language. DSA in C++, DSA in Python, all that is nonsensical. Everything is language agnostic. I mean, most of the things which are big things and useful things are language agnostic. Let's get back. I'm going to run this class once more. We have memory here. So let's say a hi. What is the temperature of Noida? Do you like this response? Okay. Now tell me, why is LLM giving this response? Why is LLM not able to tell me the current temperature of my current city, which is current temperature of Noida? Yes, it is not able to tell that because how will it have an access to it? LLMs are trained on some old data, right? Real-time data, which changes every second or every minute, it will by default have no access to it until unless you provide an access to it. So whose responsibility it is to provide an access? It is your responsibility. So we need to equip LLM with certain tools so that by using those tools, it can answer such queries. This is where comes the second limb of AI agents, which is called as tools. People also call it functions. Tool call, function call. No, this is not MCP. See, anything which can be done with MCP can also be done without MCP. Let me give you a very simple example. Let us say there are M different LLM providers and N different tools. Without MCP, you will have to do M into N integrations. You will have to link every model provider with every tool. You will have to literally link Grok with everything, OpenAI with everything with everything, M into N. But if you're using MCP, it will be M plus N. What I am saying might not make sense right now, but when I talk about MCP in a class, you will perfectly get it. Okay, those of you who know a little bit about MCP, I think you might be able to catch what I'm trying to say. But those of you who do not know, do not worry about it because that's a different topic altogether. Okay, what we are talking about is not MCP. We are talking about tool call or function call. I'll be using them interchangeably. Tool call or function call, they are basically the same thing for me right now. So before doing anything, let us just head to the screen, the whiteboard. Okay, so see, what all do we have? We have a system, we have an LLM, we have some memory. We have already discussed this, right? And now we want to have different tools. Tool 1, tool 2. Similarly, there can be different tools that I want to have access to. Let's say this is my weather tool. When I say weather tool, if I have to If I'm worried about weather, if I have to get any weather information, I'll go to this tool. As simple as that. Now, if a user query comes, tell me the temperature of Noida, what I'll do is I'll fetch the history and send that history and query to LLM. But now in the request, I'll also tell my LLM that, hey, do you know, I have got two tools with me, T1 and T2. T1 is responsible for weather and T2 is responsible for maybe movies. Okay. So if a user has asked you a query which is related to weather, if user has asked you a query which is related to weather, then just tell me that I need to call a tool T1. See, it is a very important point here. LLM does not invoke tools. LLM tool call nahi karta hai. When I say tool call nahi karta hai, what I mean, LLM does not directly invoke this tool. It tells you that a tool call needs to be made. And it sends you some arguments. So it tells you that weather API has to be called with an argument Noida. It just tells you this thing. And now you actually make that tool call. Now this is a deterministic system. This is not an AI system. This is a weather API, normal software SaaS service where you send the input Noida and you get a response 30-degree. And then whatever this JSON response is, you send that response to this LLM again, and then LLM sends you a textual response that the temperature of Noida is 30 degrees Celsius after manipulating this JSON. So I'm reiterating this whole flow. A query comes, you get the history, you send the query and history, but you also tell the LLM that, you know, now I have these tools with me. So if there is a query which you cannot answer and which you feel that tools can help you answer, then please tell me that this tool call is needed. So now the LLM will tell you that, hey, T1 tool call is needed with this argument. Then you make that tool call, you get the response, and then you pass that response again in the next chat to LLM. And then now LLM has everything. And then LLM sends you the final textual response. This is what the tool calling is. Who makes the tool call? Again, not LLM. LLM just tells you that this tool has to be called. You manually make that tool. Manually means, I mean, you programmatically make that tool call. Is it making some sense? We will see it in action, but do you get the gist behind it? Yeah. Okay. Now, once you look at the code, you will get the entire pieces behind all of this. So let us see what all things we have here. This code is much larger. So, but we'll glance through it a little quickly. So see, we have all these things. We have, this is our OpenAI client with memory and tools. We have API key, we have model, we have client, we have conversation history, everything. And now you can see I have written a method called as getWeather. This is a method which I have written, getWeather. What it does is it calls this URL. This is the endpoint. Okay. And here it passes the city. It passes the city. So it takes this city argument and it passes the city in as a path parameter, as a path variable, okay? And it makes the API call, it gets the response, and in the response, there are different things like temperature in Celsius, and then humidity and wind speed, and all these things are present. And then finally, what it does is it returns that weather in this city has this temperature, this this humidity, this wind speed, and everything. So this is a method that I have written, and what this method does is it makes the API call for this city and it gets the data from there. That's all that it does, nothing special. Okay, now let's go down. So now here what I have done is, uh, if you look at this part, this is the most important part here. This is a tools variable. And so this is how you define a tool. You define tool as a structured JSON where you tell it to LLM that, hey, you know, I have a tool or a function called as getWeather. And this is what it is capable of doing, getting the weather for a city. And the properties that it takes is a city, which is a string. and it is a required parameter. Required parameter. City is a required parameter. So if you are wondering what LLM does with it, LLM now understands that, okay, if somebody is asking for temperature in Noida, I will tell in my response to the chatbot that get weather has to be called, and the parameter for that has to be a city Noida. That city is a required city. So this tool is sent as, a parameter in the API call which you make to OpenAPI now, the OpenAI now. So now you see that in the completions create API, we are also passing the tools. And tool choice equals to auto. What it means is when I say auto, it is automatic. It means that certain times when you feel, when the LLM feels the tool call is to be made, then only it will make it. When it feels it is not to be made, it will not make it. As simple as that. Okay. So that is what happens behind the scene. And now I don't want to show you a lot of code below here. So below what happens that we are just doing that conversation history management where whatever a tool call happens, we are storing it in the conversation history. Whatever response comes, we are storing it in the conversation history. We are doing all that. So if I show you all those things, that is going to take a lot of time. So instead of that, I'll show you this thing in action. So let us just run it quickly. I'll say hi. Okay. And then I'll say, what is the temperature of Noida? See, it is taking longer. Why it is taking longer is because that API, now you can see, it's currently 28 degrees Celsius in Noida with this, that. And if you want to see the history, let me show you the history. It will make much more sense. This is the history. What happened? I said hi. Then assistant said this. Then I said, what is the temperature of Noida? Then what assistant did is, assistant called get weather with this argument, right? And then what happened? Then the tool, what is my tool? My tool is that API. That tool responded with this JSON object, which I have serialized properly. And then I sent this thing in my next request to the assistant, and then assistant replied back with this thing. Does it make sense? Okay, please understand it again, that it's not the LLM which is making the API call. LLM is not making API call. We are making API call. And if you want to show it in, if you want to see it in the lines of code, let me actually show it to you. See, here is the response which we get from LLM. Okay. And then we check if the response contains tool calls, then we iterate on the tool call that are there. And if the tool call dot function name is get weather, so if LLM has reverted back with a string get weather, then we fetch the argument because LLM also sends the arguments, and then we invoke the get weather method. So please understand, LLM is just telling you which function to call. And from that function, you are getting a clue that the get weather is to be called. Do you understand this point? So that's the idea. Now you can integrate so many different tool calls inside it. So now you can realize that where we started from. We started from a single short API call. We made it multi, and then we integrated memory, and then we integrated tool. So this is a kind of useful chatbot that you can have. Not very useful, but a kind of useful thing which you can have for sure. All right. So there is a project that we are going to work on. What is the project? So the project is that there is a company. The name of the company is ABC Infotech. Okay. This company has a project which it wants to outsource to external vendors. And so basically, imagine a company has a prototype of a project in its mind and it wants different vendors to parallelly start working on it, but it has some budget constraint. These days companies anyways are very budget constrained. So let's say this company has a budget constraint that it does not want to pay more than $1,000 for this project. So it will release a tender. It will release a tender to old clients that it has in its database. So imagine that the company ABC Infotech has already worked with old, not clients, vendors, old vendors. So let's say it has already worked with old vendors like Infosys, TCS, Wipro, and whatever. And it releases the tenders to them. It sends them the email. And then what these vendors do is these vendors bargain. Of course, they will over email. So what I want to do is I want to build an agentic system which bargains elegantly on my behalf and either finalizes or rejects the deal. All communications happen strictly over email, strictly over email. How many of us are clear with the story? Okay, so that is what we really want. Now, there are so many things over here. So in order to simplify the concept, because I have said that conversations happen over email. So one way is that I can integrate with Gmail tools. I can integrate with Gmail API and create it. But I was building this project today itself, and I did not have a lot of time to do that. If I want, I can do that. It's very easy to do that, but that's a useless thing to do because the real value is not there. So I'll be using a mocked mailbox. So imagine I have my own personal SMTP server. Let's say I have my own personal mailbox where emails come and go. And so basically what I'm trying to say is I'll not be writing emails and all. Okay, there will be some API which will be invoked, and that mailbox field will be filled. That is how it'll kind of go. Okay, so let me tell you how we can plan to implement it. Okay, so how we can plan to implement it is, I mean, this is a very good AI engineering activity because here a lot of engineering happens. You truly have to think that what are the different things that you really need. So uh, to start with, I have created some databases. So I'll show you some databases to begin with. I have some tables, like if I do select star from vendors, vendors. Okay, so these are the vendors that I have in my database, their email and name. Okay, all right. Another table that I have is select star from vendor underscore service report limit 1. So there is a table called as vendor service report, which simply contains the feedback of the vendor in the last year. So last year when they worked with me, then what their performance was, how they performed. Okay, so you can see excellent delivery for this guy and all that, all these things are present. Okay, so now let's look at select star from tenders limit 1. So there is a table called as tender. Every tender has an ID, notice, rules. Every tender has rule, and then deadline, and then created as at when that tender was created. So these are some tables, and I think there may be, yeah, there is one more table which is for our mailbox. So select star, or let's just describe that table. Describe table. Yeah. So there is a mailbox table where the things that you have is, okay, it has not select star from mailbox. Which one? Yeah. So ID, I mean, for every email, there is a unique ID, to email, from email, subject, status, and created at when this email was created. Okay. So these are the things that so these are some tables that I have just created. Okay. These tables will be handy. We will see it very handy in the time to come. And now let us look at the useful code that we have written. All right, can you see the screen? Yes or no? There is so much of code inside it, but we will try to glance through them as effectively as possible. See, I have written an agent called as a tender announcement agent. So imagine if I am the admin and if I have to announce a tender, Imagine I have an app at my side, an Android app or iOS app, where I click a button, and whenever I click a button, an API call happens, and then that invokes this class. When it invokes this tender announcement class, what I want to actually do, listen to it very carefully. I want to first query my database to find out that who are my old vendors. Now, I do not want to work with all the old vendors because certain vendors are bad. And how do I figure out which vendors are bad? By looking at their feedback. Now, this filtration, can it be done by a simple software? No, because natural language processing kicks in over here. You have to look at the feedback and figure out which vendors are good, which vendors are bad. So for this specific purpose, what I'll be doing is I'll be using LLM. So I'll be making a call to LLM, and what I'll be doing is I'll pick every vendor, and I'll also pick the feedback that they created in the last year, and I'll send it to LLM. And then I'll tell LLM that, hey, tell me positive, negative, which vendor is positive, which vendor is negative. Only those vendors which are positive vendors which have given me good service, I'll reach out to them and send a mail to them that, hey, you are respectfully invited to participate in this tender, right? That is what I'm planning to do over here. And if you look at the code, that is exactly what we have kind of done. Now let me tell you one more thing. There is one very interesting thing about LLM. See, if LLM outputs a raw text, it is very hard to interpret it. See, as human, you can interpret, but as a software, it is very hard to interpret. Software can only deal with structured data. So what I'm trying to say is, if LLM responds back that, hey, Tech Corp is a bad vendor, this guy is a good vendor, there is no way I can understand that information and pick certain vendors, because again that things comes into play. Yeah, exactly. So what I would really want is that LLM responds back to me in a JSON format. Now let me tell you one very super important thing. If you write it in the prompt that please respond back in JSON in this format, then what will happen is 70% of times it will follow your instructions, 30% of time it will not follow your instructions, because that is what LLMs do. I mean, non-determinism is in their nature. Certain times they follow your expectations more carefully, certain times they don't. So here, in all such sorts of scenarios, when you expect a JSON response, a structured response, the way to go ahead is function calling. So what you actually do over here is, so I'll tell you, I'll show you a function, a tool that I have written. So what LLM will do is, LLM in its response will make a function call. The name of the function will be select vendors. And if you look at the parameters, it has an array, and inside the array, it has these properties. So it has the email ID of that vendor, name of that vendor, decision, and reason. And here it is clearly stated that decision is an enum which is positive or negative. So this is a way in which you can force the LLM to always return to always return a response which is a function call, which is a function call. So now if you look at the code where the actual LLM call has happened, you can see here I have said tool choice type equals to function and function name equals to this. So what this line does is this line forces the LLM to always send its reply via that function call. And when that function call is made, that entire big JSON is sent, which is a proper structured thing which I can iterate on. So this is a great practice. So whenever I work on top of LLMs, I always advise LLM to return me a function call. Because if it does not return me a function call, it can return me any gibberish thing, right? So you will see whenever you are doing AI engineering, you will mostly be dealing with, function calls. LLMs making function calls. Even their response is a kind of function call. Can we create a tool for LLM to call the database query? Exactly. That is one thing which we have done in this exercise also. So I mean, this question can stem from the fact, imagine you have a lot of private data stored in S3 or your MySQL database, and there is a user query which needs to be entertained via those databases. So in that case, what will happen? You cannot allow LLM direct access to it. So LLM will return a function call, and then you will recognize that, okay, for this function call, I need to fetch the record from database, send that record to it, and then it'll send you the response. So these are the flavors which tools have, the tool callings have. Okay, let me brush you directly through the code. So these things are simple, API key, client, and everything. Now, there is a class called as database accessor. Database accessor is a simple class which is used to interact with the database to do CRUD operations over there. Okay. So what happens is whenever a tender is announced, you say that there is a tender notice, and then there are rules, and then there are deadline. You say that this tender expires in next 10 minutes. No tender expires in 10 minutes, but we will do this exercise of 10 minutes. Expires in 10 minutes. So what it will do is it will create a tender in the database. Okay. And then it will fetch all the vendors with latest feedback. Okay. And then it will create a vendor payload where you will have email ID of the vendor, name of the vendor, and feedback of the vendor. Okay. And once we have this vendor payload, you can see we are dumping this. We are dumping this vendor payload in the user prompt because it needs to go all the way to LLM for LLM to analyze, right? And now you can see that, okay, you can see that there are some retries. I have configured these retry logic because certain times LLM calls might fail because of transient network issues. Okay, or maybe the server is too busy. So you can make, this is a simple thing, right? If you have done basic software engineering, whenever you make API call, you generally configure some retries. So I make an API call, and from there I get a response, right? And now I extract the tool calls from it, right? And now I know for sure that in these tool calls what I'm going to have is decisions, and those decisions will be positive negative for everything, for every vendor. Now I'm iterating on those decisions, and if I see that a decision is positive, then only I am sending the email to that particular person, to that particular vendor. So that is what I am going to do. So this is the logic which is contained over here. Okay, to simulate it, what I have done is I have invoked this announce tender for this tender notice that we are inviting proposals for cloud infrastructure, blah, 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 whatever, AWS, Azure, whatever. And you have been chosen as this. Please revert back with your pricing proposal. Hurry up because the deadline is 10 minutes. Okay. Vendors must have positive feedback. This is an important rule, okay, from previous engagement, and the budget is $1,000 US. So these are the rules. This is the deadline, and now this tender announcement is done. So I want to show you what really happens when this tender announcement agent kicks in. When this tender announcement agent it kicks in, these are the jobs which we expect to happen. So, but before that, what we'll do is we'll look at our database. Yeah. Select star from vendor underscore service report. Okay. I said I am interested only in the feedback of last year. The current year is 2025. So 2024, Tech Corp had this feedback. 2024, Innovate Systems had this feedback. And 2024, Global Tech had this feedback. So there are three vendors. The third vendor had this feedback, the second vendor had this feedback, and first vendor had this feedback. So what do you think? How many vendors should ideally be invited by this agent? Only two. Why? Because the third guy messed it up. The third guy had a poor quality of work. And if my agent really works well, if my agent code really works well, it should make sure that only two emails are sent, and that too to Innovate Systems and Tech Corp solution, right? Okay. Another thing that I want is that when a new tender is created, its deadline should be 10 minutes, strictly 10 minutes, right? Because that is what I have configured. In reality, it could be 5 days, 6 day. I can pass an input like that. So I'm just stopping it right here, and I'm just going to show it to you. So if I go back to this tender agent, and if I just try to run it, so let's say run this button. All right. So see the logs. It says created tender with ID 26 and sent tender announcement to two vendors. And I'm quite sure that those would be only those two vendors. So it looks like LLM has worked perfectly well, and this agent has done its job. This agent has created the tender and sent the email and done all those things which it was required to do. So now if I go back to my database just to check if it has done the job rightly or not, what I'll do is, what was the ID? Was it 26? Select star from tenders where ID is 26. All right. Deadline and the other thing is deadline and the created at time. So you can clearly see it here that, yeah, 9:45 is the created at time and 9:55 is the deadline. So it did good job. Literally did good job. Now, if I do select star from mailbox, order by created at des limit to, then I can literally see that it has only sent the email to Tech Corp and Innovate. This is the subject, new tender, we are inviting blah, 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 whatever. And this is the second email. So this is a very, very small agent in action, which has done a very small job. Yeah, I can fetch the top three, and I'm sure that the third one would not be that because uh, you could see the logs. The log said that, okay, let me do that for you. Okay, so if you see this screen, you can see this is the third one. Third one is Tech Corp, and its timing is also different. It is 3:37. So this today I did when I was building this, it's log of that. Okay, so the mail did not get sent to the third guy. Okay. All right. So this is just first agent. The most important thing is the second agent, which does the bargaining and all that. So this is where the real intelligence lies. So now head back to the real stuff. So for this, I have created a multi-agent system. Okay. And you will realize why I have done that. See, the idea behind multi-agent system is if you ask one agent to do everything, it will not be able to do anything perfectly. It's just like you have learned about single responsibility principle, write multiple functions, write multiple classes. The same thing is with agents. If you have multiple specialities, you should have different specialized agents. So the first agent I have created is planner agent, main planner agent. Let us look at the things that it has. Okay, so we will look at it later, but first we'll look at the system prompt. I want all of you to read this system prompt. Every one of you should read this system prompt. Just go through it quickly. I'm just reading it. You are an email processing agent for procurement team. Your job is to analyze vendor emails and determine the appropriate action. And you have to analyze the tender details and vendor email history to determine the appropriate action. So for here, what it says is that if uh, let's say you received an email, if let's say a vendor sent you an email, and if that email has been sent after the deadline, then you do not need to do anything, simply ignore. But if that email has been sent before the deadline, then you need to process it normally. So that is the first thing, because certain emails might keep coming even when the deadline is lost, right? And now these are the rules. So ignore, you understand when to ignore. Then there is something called as fetch past year conversation. So here it says that if the current email from a vendor refers to some communication that happened last year, then call this function. Because see, certain times a vendor might write an email saying that, hey, last year तो मैंने इतने में किया था, इस year तुम इससे कम में भी दे रहे हो. So they might bargain like that. They might say that last year we did in this amount, this year it is even lesser. So you might want to check. So in that case, you might want to fetch from the database. Now, those of you who are listening carefully, you can realize this is the time when a tool call will happen. A tool call will happen, and from the database, those records will be fetched and sent to the LLM, right? Then bargain. Bargain means If the vendor is talking about price in his email, then you must look at the tender rules to find out our budget. And you can see in our rules, the budget was 1,000. Also remember that we won't ever close a deal that is asking for more than 10% of our budget. For example, if our budget is 1,000, we won't ever close a deal that's asking for more than 1,100 US dollar. So these are the instructions which are being sent in the system prompt. This information is for our internal use and you do not need to tell vendor about it, of course. If vendor's price is higher than 10% of our budget, then you can call this function. Do not call this function if vendor has stated that he cannot lower his price. If vendor is not ready to bargain, there is no point of bargaining, right? Then send to info desk. If there are some general info requests, like let's say if a vendor has requested basic thing like what is your GST number or something like that, then you can call send to info desk, and if info desk has that. So basically what I'm trying to say is that for bargaining, there is a special agent. For fetching this, there is a specific tool. For finalizing the deal, writing an email for finalizing the deal, there is a separate agent. For polishing the email means that an email has been crafted, but then you realize that you sort of realize that, hey, this particular email that has been crafted is not professional, so let's polish it. And now if you go back, corresponding to all of them, there are different functions. So there is a function called as polish email. So polish email function, who calls this function? LLM. When LLM realizes that the current crafted email needs polishing, it will call this. If it realizes that now we can finalize the deal, it will call this. If it realizes that we need to send to infodesk, it will call this. And corresponding to all of them, corresponding to each of them, there are specialized agents. So you can see there is an infodesk agent. There is a bargaining agent. Bargaining agent has its own special prompt which says you are an expert negotiator, and you look at the tender rule and see these two rules are important. The first rule is that if it is the first email from vendor regarding the current tender, then your email should just ask him to reconsider his price. Do not propose any price. Okay. And if it's the second or third email from the vendor, then you can propose a price from our side, which is exactly same as this. So these are the things for bargaining email, bargaining agent. This is how bargaining agent functions. There is another agent which I want to show you, which is deal finalization agent. Deal finalization agent, what it does is it actually finalizes the deal. So if it sees that the pricing has not worked out, it writes a closer email. And if the pricing has worked out, it invites the vendor for a face-to-face meeting. So yeah, so basically there are different agents doing different things. Now, if you go back to the main planner agent over here, let's see the core logic, the important logic. So how it functions is when it runs, in every 5 seconds, it polls the database. In every 5 seconds, it polls the database. So that code is written over here. You can look at, if you have an idea of async IO in Python, if you do not have, just imagine it's a separate thread. All of you know about thread. It's just a separate thread which polls the database. Yeah, you can see threads have their signal handler so that those signal handlers are present, right? And so it pulls the database in every 5 seconds. And what it does is it fetches the latest email and then it figures out the best possible reply that it can send for that email. That is what it does. Okay. I want to show you the demo of this through which probably you'll be able to relate. But before that, one more part. This is the core logic. Okay. So what it first does is it sends the entire conversation message to OpenAI. And conversation message, it contains literally everything. It contains standard details, current email which has come, the email history which was there, everything. No, tools and agent are different. Tools, there is a slight difference between them. Okay, but ignore those for now. For now, let's just look at this thing in action, how it works. It calls OpenAI, and OpenAI will respond in some function call. So if it sees that the function call is ignore, it ignores. If it sees that the function call is to fetch past year conversation, then it fetches the past year conversation. If it is about bargaining, it calls the bargaining agent. If it's about sending to Infodesk, it sends to Infodesk. If it is about finalized deal, it finalizes the deal. If it is about polishing the email, it polishes the email. If it is about finally replying, then it replies and it also breaks the loop. You can see in other cases it is not breaking the loop, because in other case it's like a flywheel. Like an email comes and then first it realizes I need to bargain. So bargaining agent, it creates a bargaining email and then it is sent to the OpenAI again. And then OpenAI realizes that, hey, this bargaining email, it needs to be polished. Then polishing happens. Then that polished email is sent to LLM again. And then LLM says that, yeah, now you can reply. And then finally reply happens and then you break out of the loop. So you break out of the loop. So you understand this is a while loop. This is a while loop. And this while loop continuously makes OpenAI calls only when OpenAI reverts back by saying that, yeah, now this email looks good, reply, then you reply and then you break out. Otherwise, you keep going. You do whatever it says. It says bargain or polish or whatever it says, it kind of keeps doing that. Okay. Look at it and action. Okay, one more thing. I have written one vendor email helper. This is just, uh, a separate class through which I can simulate the process of a vendor sending an email. Okay, so let us get going. So I'll go back to tender announcement agent. So I'm at tender announcement agent. I am going to announce a new tender. All right, so a new tender has been announced. Okay. Now what I'll do is I'll just go to the planner, which is my main planner agent. Okay. This is my main planner agent. And here I'll kickstart it. Now it has started running. So it is going to poll every second and no mails have come. So far, no mails have come. So you can see it polled at 9:58, 5 and then 9:58:10 and then 9:58:15 and then 9:58:20. So it is going to perform polling after a duration of every 5 second, 5 second, 5 second. So far, no email has been sent. Okay. But now what I'm going to do is I'm going to change my terminal and I'm going to go to the other class, which is for sending the vendor email. And here I am going to just simulate sending an email where Innovate will send an email that, hey, we are an expert and we need 5,000 for this project. Okay, so I'm just going to run this. I think we need to go back to the previous. I will run this. Yeah, email has been sent. And now let's come back to main planner, which is here. Now you can see here the things happen. So the first function call was for bargain. And as a consequence of that, this is the email which has been created. Dear Sir, Madam, thank you for your proposal. However, we would appreciate if you could reconsider a quote of 5,000 as it is significantly above our allocated this. And now this email is sent in that while loop to the OpenAI again. And now you can see that OpenAI said that, hey, polish this email. So now we polished this email and this is the polished body. The polished body is, dear sir, madam, we extend our gratitude for this, that, and however, we wish to bring to your attention this thing, right? And now this polished email is sent to OpenAI again. And now the third iteration of the while loop happens. In that third iteration, OpenAI says, okay, now reply. When it says reply, the actual reply is made. So this is the actual reply which has been made. So now this email has been sent by my planner agent to this particular guy, which is my vendor. My vendor. Okay. So now my vendor would see that email, which is Innovate, and it would probably write another email, another follow-up email. It would say that, it would say, hey, can we do it in 2000 USD? Can we do it in 2000 USD? Okay, that is what it says. And I'll save it and just trigger this call. So now this email has been sent. And now you will see it will catch it. It has caught it. And now you can see that in the first iteration, it has said So see, if you remember, it has followed the rule. The rule was that when the first reply is being said, please do not mention $1,000. In the second reply, you can. So here it has mentioned that, okay, our budget for this is $1,000. We kindly ask you to reconsider and blah, blah. Now, LLM says, please polish this email. So the polished email is this, we sincerely, blah, blah. And then you can see the same thing. The facts are the same, 1,000 US dollar. And then finally reply. So the reply has been made. And then this is the final reply, which has gone through, right? Now I'll again come back to the vendor and change the terminal. And now I would say that 1,050 USD is my final price. Okay. And if you remember, we had set a rule that 10% is tolerable. 10% is tolerable. This was the rule. So 10% of 1,000 is 100. So 1,050 should be tolerable. So now if I send this email, I'll expect to catch it here. And you can see it has been caught, and immediately you can see that finalized deal has been called. And now that deal finalization agent has created this email. And after that, it has been further polished. And this is the final thing. We are thrilled to inform you this. So did you see the chain of actions that happened? The vendor started with $5,000, then something happened, then he came back to 2,000, then 1,050, and that is how it finally got agreed upon. Could you understand the flow? How many of you could relate with the flow? Just type in yes or no if you could. This is a somewhat useful system. This is a somewhat useful system in action. And now you will see if more than 10 minutes has elapsed, if more than 10 minutes has elapsed and um, somebody still tries to send an email, then it will just be ignored. It will simply be ignored. Okay. You want to do another run to see another example, you can see that also. So let's go to the tender agent. Where is the tool calling made here? At so many different places. This code is huge, so it probably could be a little hard to figure things out. Since the rule was not to send the budget before two mails, but it's sent after the first mail, is the agent penalized for making mistakes? The rule was not to send the $1,000 thing in first email, but to send it in second or third email if needed. I think the email followed that instruction here. But if the but certain times LLMs hallucinate. That is where prompt refactoring comes into scene. That is where evals come into scene. So you write even, so this is just one example. If I run this for 1,000 examples, it may happen that for 5 or 10, or I don't know, maybe for 50 or 60 example, it behaves badly. That is what is to be caught, and that is what is to be fixed. So that's a different thing. Okay. But this is generally when you build an agent, it is 60 to 70% good. But for every 5% improvement, you have to toil really hard. That's a different science that you do. How to test such system? Evals, evals, evals. Okay, evals are the way to test such systems. Uh, okay, so let's do one thing. Let's test it for one more use case before we shut down for the day. I am at tender announcement agent, and I'm going to announce. Let's announce the same tender again. This is what tender announcement agent, and we announce it. So we have announced a new tender with tender ID 28. Now let's go back to the main planner agent. In the main planner agent, let's quickly run it. So main planner agent has started working. And now let's switch the terminal and go back to vendor email. Okay. And send an email from here saying, hey, let's say this guy is quite expensive. Is my price. So this is what this guy starts with. And we will just send an email from here. So the email has been sent successfully, and we come back to this and we realize that the bargaining process has started. So the bargaining process has started, and it kind of bargains, goes on. And this is the final email which is sent. Thank you for submitting, blah, blah, and all that. And it says that please come up with more competitive offer. And then let's say this guy is a little stubborn guy. So if you go back to this, switch the terminal. This guy says that we don't do lowball pricing. 5,000 is the best I can do. That's my last oath. Okay. Let's say this is what he sent. Save it and send it. So now it will be caught. It will be caught by that polar. Yeah, it caught it. And you can see it still tries to bargain. Yeah, it still tries to bargain. And it again says that we respectfully request that the pricing strategy is, whatever it kind of says. And then finally it says that, finally, let's say this guy says, uh, 5,000 is the best I can do. I will not come below it. Take it or leave it and close. Something like this. And this. And now you switch and you run and you come back to this. And now you see it says कि बहुत हो गया, अब finalize करते हैं. Now let's finalize the deal. When it finalizes the deal, just hold on. I think we might have made some mistake somewhere. 5,000 is the best. I think we might have made some mistake in some flow over here, because it should ideally not have got accepted. Okay, let's change it for. Okay, so basically what will happen is that uh, eventually if it realizes that uh, this deal is way beyond 1100, it would even end up rejecting it. And if at all you notice that it did not reject, that means you need to tighten your prompt more. So if you ended up realizing that, okay, it ended up selecting a deal of 5,000, which is well beyond 10%, you need to tighten your bold more. But that should not happen because I tested it on some other examples and that literally did not happen. But yeah, we made a mistake. It was actually picking the last conversation. That is the reason it happened. I have to clear some data from database and then it will work well. Anyways, let's put a pause here. All right, so cool. Yeah, we don't need to tighten system prompt in this case. It was a mistake because there were some stale entries in the database. I forgot to clear those entries. Once I clear, it will pick those entries and then it'll work on top of those. Yeah, and it'll work well. So yeah, cool. Does that give you a clue of, I mean, it might have been too much for the day, but does that show you that how you can use AI to do some engineering and create some product out of it? So I wanted to do this exercise because I actually wanted to tell you that AI engineering, how it is different from classical AI/ML. In classical AI/ML, you do not do this thing. In classical AI/ML, you work with back propagation, you work with data cleansing, you work with all sorts of things. But in AI engineering, this is exactly what you do. You deal with threads, you deal with databases, and you sprinkle LLM calls wherever they are needed. And then you orchestrate you control and coordinate the communication between different agents and different tools, and you tighten the system prompts. This is what you do. And how you tighten system prompts? Via evals. Evals is a big topic we will probably talk about in a separate session. Okay. Cool. I hope it was helpful. So we spent almost more than 2 hours, and I believe it might have given you some idea around what AI engineering really is and what it is not.